We are group MTA18539, studying meteorology at Aalborg University. For our 5th semester project, we decided to investigate what parameters are important when making a perceptual, realistic, augmented reality application. To accomplish that goal, we needed to find out what makes a 3D model blend in with the real-world environment. To do that, background research in the fields of image effects, shaders, real-time rendering, and existing solutions was conducted. The findings from the background research showed us that the parameters blur, shadows, occlusion, noise, and downsampling could be looked into for better immersion of a 3D model in an AR environment. Next, the final problem statement was formulated: which parameters have the biggest impact on perceiving how a 3D object blends in an AR environment on a mobile device. With the findings and the final problem statement in mind, we created a mobile application using AR Core to put a 3D model of a bird bath wherever the surface could be detected and apply different image effects on top of the camera feed. To evaluate the application, we designed 2 experiments, first to determine what the best value for the effects would be, and second to test which effect has the biggest impact on the perceived realism. During the first test, participants had to rate what they saw on the phone screen in 2 different aspects. First, the quality of the image, and secondly, the perceived realism. Both were rated using a Likert scale ranging from 1 to 5. This testing session allowed us to set up the perfect variables for the effects to be used in the second test. The perfect variables were found by taking the mean of the results per parameter. To additionally check if there was a difference between each state in a parameter, a one-way repeated measures ANOVA was run. The most noticeable parameter was the shadow intensity, which after analysis revealed a significant difference. Like the first test, the second testing session expected the participants to rate the scene on the same quality and perceived realism aspects. After each rating, one of the parameters was turned off in a random order, and the scene was rated again by the participant. With all the gathered data from the second test, a one-way repeated measures ANOVA was run on the data to see if there was any significant difference between the parameters. The results showed that there was no significant difference between each parameter, which rejects their individual hypothesis of them affecting the perceived realism of the AR environment. Unfortunately, we cannot know this for certain due to errors during the testing procedure, causing the results to not be valid. With proper results, it would open the door for future work. Areas like the threshold between the quality and the perceived realism could be analyzed to provide the user with good immersion of the model while retaining relatively good quality of the image. Another aspect that could be looked at is how computationally costly each image effect is and how important they are compared to the perceived realism they provide. In conclusion, each parameter was implemented in an AR application, but tested in a non-optimal way and would require further testing to be deemed usable.